Okay, we have a room that's measuring 20 by 18 feet. And we are trying, I'm just gonna put an R there because that's my real thing. And I'm gonna try to put it on a piece of paper. And then my paper is 8.5 inches by 11 inches. So I'm just gonna put a little D there to remind myself that that's my diagram part. Real life diagram part. Okay, we're gonna be trying to make this a scale, and I can't do that when I have a mixed amount of units. Because something was in feet and something's in inches, that doesn't work very well. So what makes more sense, to produce everything in inches or produce everything in feet? Inches makes more sense. So I'm gonna times by 12. You good with that? Timesing by 12. Okay, so what I'm going to do is I'm going to connect, obviously, the longest side of my bedroom. When I draw it on the paper, would it not make sense to put the longest side of the bedroom on the longer side of the paper? Does that make sense? So I'm going to connect those numbers together, and I'm also going to connect the shorter side of the bedroom to the shorter side of the paper. Can you tell me what those would divide to be? Each of them. So I got a 21.8 and a 25.4. Okay, so I have to pick, obviously, just one consistent number. Do you guys understand you can't shrink something by one number and the other one by a different value? Then you're not making your bedroom proportional. Okay, so I have to shrink it. I need to shrink it probably even smaller than the paper so that I can fit it on the paper. So can you pick me a number that would make sense to you? How much would you want to shrink it by? 26. That's a good number. 30, good number. Okay, so if you're picking 26, where would you put 1? Where would you put 26? Diagram to real life. Which thing is a bigger thing? Our diagram is bigger or our real life is bigger? Real life is bigger. So there's my scale. For every 1 inch on my paper, it's going to show me 26 inches in real life. So now I'm actually going to show you this bedroom on my paper. Okay, so if this is my piece of paper, ready? I'm going to take the long side of the bedroom, so 240 inches. I'm going to shrink it by 26, which is going to be 9 point. So this bedroom is going to be 9.2 inches on my paper when I draw it. And I'm going to do the same thing. I'm going to shrink this side by 26. So 216 inches, shrink it by 26, 8.3. inches. So now I'd be able to draw out my bedroom on this paper. Okay? Obviously, you have a little bit of room on the edge of your paper. That's great.
And you can just pick any number, like that we got 26.
Any number bigger than, so you have to be bigger than both of them to shrink it, right?
Yeah.
Because if you only used 25, okay, then this wall, if I shrunk this wall by like 25, 216 divided by 25, it's 8.64 inches. And like now, oh, I can't get that onto my paper. Yeah, you have to be bigger. Okay, there's a 100% chance that question's on your test, by the way. A 8 by 12 picture has dimensions that get tripled. So what is that? When it says just the dimensions, that is going to be called a, do you remember me labeling it? Linear scale factor. The sides, that's linear. Linear scale factor is 3 times bigger. How much bigger is my area going to be? So the side walls are going to turn 3 times bigger. My area is going to end up being, it's not 3 times bigger. What are you supposed to do? Square it. The area is going to be 9 times larger. What is the new area? Okay, so just if I have a square here, the area is 96 inches squared. I'm going to go area 1. So what is area 2 going to be? Area 1 was 96. Area 2 is 9 times larger. Okay, so do you remember that? You were supposed to put some of that stuff on your cheat sheet, understanding going from linear scale factor to area, you got to square it. Okay? You could have done it in a different way, but I'm not going to show you that way because I don't think I have that one on the test, but you could have tripled. So that side would have been 24 and 36. And those should times to be that. And they do. Okay? So if I tripled that side and I tripled that side and then did the area, you get the same. Okay, Chad and Charlene painted a mural on the wall measuring 12 feet by 8 feet using a projector. The original had an area of that, so what's the scale factor? Okay, I'm gonna go OG, original. The original was something probably on a paper, and then they projected it and then wanted to draw it on a wall way bigger. So what do I know? I know the area of that. And on the wall, I know the dimensions are 12 feet by 8 feet. So I can find the area of this one, but I don't want to use feet because this is in inches squared. So let's go to inches here. How do you go feet to inches? times 12, so that's 144. And times 12 is 96. Can you times those together to get me the area of a rectangle? Okay, so I've obviously enlarged. I need my scale number to be something more than 1. Okay, can you go, I always do it new divided by original. New divided by OG. So give me this area divided by that area. Area 2 divided by area 1 is 64. 64 times bigger. The area is 64 times bigger. So this is called area scale factor. The area was 64 times bigger. Okay, but that's not my answer. I want my scale factor, which would be just my normal sides. So my linear scale factor is obviously going to be the walls would have had to have gotten bigger. How much bigger would the walls be getting then? They're 8 times bigger. Why? Because I was in area. How do I go from area to linear? Square root. Okay?
What did you square root?
64. Yeah. Okay, a circle has a diameter. Do you guys know what diameter means? Across. Then I reduced it, and then I got smaller. So what do I know about my scale factor already? My scale factor better be something underneath 1. Okay, so we're going to go new divided by original. That's the plan. That's the usual idea. So 7 divided by 56. That's my scale factor. I reduced. So my scale factor is 0.125. Okay. What kind of scale factor should we call this? Is it the change of sides, area, volume? Which one? Linear. Because it was a diameter, which is just a 1 dimension. So what is the scale factor for the areas? So I want to know what's the area scale factor. So what am I going to do? How do I go from linear to area? Square it. So I'm going to square it. Okay. Did anybody know how to do their calculator with fractions instead of those decimals? Do you know how to do that? So 7 divided by 56, and it gave me a decimal, but I have this button that can go to a fraction. So that was 1/8. 1/8 of the size. And then when I square it, that's 1/64. So you could have had that 1/8, which 1/64 of the size of the area. What's that? I have this button that looks like this.
right above my number.
It's nice and handy. You might have something that looks like arrows in a circle.
Okay. What time is that number? What? Shouldn't if it's 164, shouldn't it? 164.
I can come look after and see if I can find yours. It's not a big deal. You can have decimals too. Okay, the area of the first rectangle is 900 centimeters squared. Okay, the area of the first rectangle is that, and then the area of the second rectangle is that, all in centimeters squared. Okay, so I've shrunk it. So my scale factor needs to be a small number because I shrunk this. So this is my OG and this is my new. Okay, this was the original and then I shrunk it. Okay, so new divided by original. The new one divided by the OG. So 10 over 900. So the scale was 0.011111. What should I call that scale factor? What's it comparing? The area. So what scale factor should we use to change the sidewalls? Square root that, because I'm in area. How do I go from area to just... So I'm going to square root. You better use that button called answer button. Don't retype anything. Okay. Did you not get that? Why, you're just making more work for yourself. Okay, I'm going to throw in an additional part because this is on your test. What if I told you this one had a bottom side of 4 centimeters? Could you now figure out the bottom side of this one? Okay, so now I want to throw this on your cheat sheet. This would be something good to add. Okay. So this is something that I'm going to have on my cheat sheet. A scale factor is always a new divided by original. Okay, scale factor is always the new divided by original. You guys already have it on there where if it's getting bigger, it better be over 1. If it gets smaller, it better be less than 1. Okay? Now, if I want to go, if I have the original and I want to know the new, I would times by the scale factor. If I had the original, I would times the scale factor to get the new. If I had the new and wanted to know the original, what do you think I would do? How would I work backwards? Divide by the scale factor. Do you see that? So that's great to have on your cheat sheet, something like that. Does that make sense if you draw it out like that? If you have the original times by the scale factor to get the new, okay? Okay, so can you now get me the original bottom of this rectangle? So the new bottom had a 4. This is the comparison of the sides. Don't use this. This is the comparison with the sides. So this divided by that. So 37.95 centimeters. Okay? FYI, if you did it wrong and you times it, you would have got a really small number, and then you should have had a red flag in your brain that said, that doesn't make sense. Because you know that this stuff has to be bigger than that stuff. So if you did it the wrong way, it just makes sure you see that red flag that says that doesn't make sense. Okay, a water bottle has a volume of 16 ounces, and the drawing had a scale factor of 0.4 for the dimensions. So what's the new volume on the diagram? Okay, so I had a water bottle, 16 ounces was a volume. And then I was to draw it on a paper, so I was obviously shrinking it. So OG, and then on this diagram, I was shrinking it to fit it onto my diagram. Okay, so 0.4 was a scale factor used for the dimensions. So when it says for the dimensions, what is 0.4? It is a linear scale factor, just linear, because it's only doing the dimensions, like a radius, a height. Okay, so there's my linear scale factor. So what is the scale factor about how the volumes would change? What would you do? So volume scale factor. How do I go from linear to volume? I need to, how do you go from linear to volume? You cube it. So 0.064. So now the final question is, what is this volume? I did this cubed. 0.4 cubed. Not cube rooted, cubed. 0.4 cubed. Like that? 0.0. What? You have cubed root. You have a root symbol in front. I'm cubing. Yeah, cubing, like to an exponent of 3. Now it worked? Okay. Okay, anybody figure out how to do this? So we just wrote it on our cheat sheet. Right here. What do I want to know? I want to know something about the new. So I'm going to take the original volume. I'm going to take volume 1, which is 16. I'm going to times it by the volume scale factor. And the result will be the, does that make sense? The original volume times the volume scale factor will get me to the new volume.
Put that thing back.
Like this thing?
Oh,
Okay, so 1.024, and I need to write something on it like ounces. Okay, so cheat sheet stuff. Let's talk maybe